breaks down. And so when I was at Docomo, immediately so many people, it's almost impossible to connect to the some of the particular location from Tokyo, because NTT Docomo always have a very sufficient enough capability or capacity to enable our customer to be connected. However, once some of the physical network is down during the huge damage like a disaster, it's quite difficult to keep such a connection, even though some of the location is not totally independent from earthquake places, because the base station is most likely in the east and the north side in Japan. But many of the traffic jam is always happen from a metropolitan area, for example, in Tokyo. Tokyo is totally far from an earthquake center, and there's no any damage, physical damage in terms of base station and fiber. However, many of the congestion and almost disconnection may happening inside Tokyo. And given that, regardless of how physical network is still survive, but a capability like EPC or IMS, it's impossible to handle all the such call attempt. And then Docomo and the Japanese government decided to how we can build up the more robust network. That's one of the motivation which at that time I was in charge on the EPC design and what the 5G network looks like in 2011, 2012. And immediately my responsibility was immediately changed to how NTT Docomo can build up their robust network even in the disaster cases. And that's 2012, 11, and 2011 and 2012. And in the meantime, many of the other operators like AT&T or Verizon or Deutsche Telekom or Telefonica or Vodafone have that's totally regardless of the disaster cases, but many of the mobile operators all over the world thinking about a very similar way. So how to build the more cost efficient but quite more resilient network in the mobile industry. So that's 2012, and you may know or not, network function virtualization, we are calling the NFV. NFV started with among the very small operator, and that's a 12 operator in the white paper, and I'm one of them. And we started the NFV. We mean such an operator decided to ask for Etsy to host such a standardized entity. Is okay? Okay. So that's the motivation which what I started the Etsy NFB. And then after the 2 years, we realized that sometimes the standardization takes time. But industry is moving very, very faster. And we also decided to accelerate such a movement to make it happen in the hands-on. We decided to ask for Linux Foundation to initiate the OPNFV. And now OPNFV is a part of the Linux Foundation networking, including FIDO and OPNFV and ONAP and so on. Those kind of things is many of the operators, as well as Intel. Of course, Intel is one of the founding members as well. At that time, so Sandra Rivera, so she's now in the SVP in the Intel. But so when she was in the director of the Intel, we also discussed so many times, and we decided to accelerate the such NFV and this technology into a commercial carrier grade requirements. That's one of the OPNFV journey. And then after that, so I personally moved to Cable Labs and started the very similar journey inside the cable industry. But one of the problems which I was facing was, cable industry is much conservative than telecom industry, and they are not be aware of how important it is and what is the potential benefit from a virtualization. And I try to talk to how good it is, what is the potential benefit in the capex and opex, and also more resilient network in the cable. And now I studied what's a DOCSIS and what the cable networks looks like. And a couple of you already knew that DOCSIS is a standard, certified by Cable Labs. And DOCSIS stands for Data over Cable Service Interface Specification. That's kind of a data protocol specification, standard by Cable Labs. And DOCSIS is spec between the CMTS. CMTS stands for Cable Modem Termination System. That's a kind of a MME, EPC, without mobility management. That's a kind of a termination point, in the mobile network. Customer promise. All the our cable operators customer inside the home, they're gonna put the cable modem and the STB set-top box. And DOCSIS is some specification between the CMTS and cable modem, and then so that the movement is quite similar with the mobile and the telecom industry. So what now cable industry is doing is to disaggregation. And like maybe MEC, like all the, some of the very latency or throughput critical functions should be more disaggregated. But all the central control plane will be fully centralized. So previously in the legacy cable network is fully separated between data connection, terminated by CMTS, apart from ECAM. That's a kind of a video streaming, content streaming. That's fully separated, but nowadays we are calling a CCAP. CCAP is a converged cable access platform. It's consolidated all the data function, both of the downstream and upstream, with video streaming. Because especially in the US, so all the connection in the all IP, that's a little bit different from Asian, including Japan market. But especially in the US, like a Comcast or Cox or Charter, those guys are very easy to consolidate all those kind of. But very corresponding similarity, we are saying that the head end in this side. And usually head end is a CMTS or CCAP, it will be located. And the fiber node side, that very close to a customer edge. That's maybe in the terminology point. For a mobile industry, we are saying that the customer edge. That's a fiber node is many of the very latency or throughput critical function is only be distributed in the edge side, but many of the other control planes should be more in the central office, like a head end. That's the current trend. And of course, all the connection is from analog optics to digital. And all those kind of connection between the head end and the fiber node will be layer 2 connection, because as long as such a fiber optics 5 layer can support any layer 2 technology like EPON or GPON or Ethernet, whatever. So that's very easy to deploy on top of the such digital optics. And more dig insight. So what's DOCSIS protocol looks like? So we categorize DOCSIS into 3 categories. One is DOCSIS Y, and which includes some modulation of bit, like RF output and upstream and downstream. And also second layer is DOCSIS MAC. So MAC layer is very similar as any telecom and mobile industry, but some layer messaging like a QoS and rate shaping, and also of course all the data must be encrypted. And also layer 3 and higher is more also very similar with mobile protocol, but SMMT agent and the DHCP proxy and so on, and also forwarding L2 and L3. So those kind of protocol stock can be purely virtualized. However, some of the very specific hardware dependency still exists, especially in the DOCSIS 5. So that's one of the reasons why DOCSIS 5 protocol stock should be still depend on some specific customized hardware in the fiber node. And so what I'm talking about with our member, like a Comcast or Charter or Cox, and any other cable operator all over the world, is how such a kind of a virtual
CCAP, like very close to a virtual EPC, is how such a virtualization is have a huge benefit, not only just a cost point of view, but also availability and some agile, almost the same benefit I'm talking about with our member. So when I was in NTT Docomo, and so what such a transition looks like is. Previously, still existing CCAP is located in the head end, while fiber node has and still Mac some functionality. And then, so what we try to transit from now to more virtualization centric will be many of the such layer 3 and upper, and also DOCSIS Mac should be more in the data center side, and stay DOCSIS 5 is still stay in the edge. Edge node, like a fiber node. And now, so it's time to talk about the network slicing. But before that, so what we already achieved with Intel, that's already in the public because last year we are very closely disclosed only with our member. But after this year in January, we decided to disclose to everyone. And that's one of the reasons. Maybe this is our second time to talk in such a public space. But so what we did from 2 years ago, mainly in the last year and this year, was to work with some partner, including Intel and CASA. You may know or not, CASA is one of the huge supplier for CMTS and CCAP in the cable industry. And what we did is, given that cable industry is more than cable, because cable revenue is quite shrinking, you can imagine that. So that's why many of the cable operator is try to expand their business into mobile space. That's quite the obvious reason. And what we did in the demonstrated is a more converged network between DOCSIS and small cell. And those kind of small cell station will be was provided by CASA. And Intel also provided with a cable modem in their Puma 7 gateway. And RPH, that's a remote PHY. That's you may still remember. Remote PHY function stack is fully distributed in the fiber node. That's edge, custom edge. And this is this very close to a cable modem side. And the coax, HFC network is a connection. And from this CASA's remote PHY devices into a cloud, and based on OpenHB and OpenStack compliant, our carrier-grade SAMA infrastructure on top of the OpenStack. And by the way, we are now trying to move to a Kubernetes and the Docker container, but so far, so our achievement was to based on the OpenStack. And then on top of the such a Intel server, so we are deploying in the virtual CCAP, and on top of that, so we are also developing and deploying and integrated with virtual EPC. That's what we achieved and already disclosed in the public space. Well, that's a very good one of the example to show how cable industry is moving forward, and including some virtualization. And then, so in the context of the network slicing, you can imagine what can be next. And given that 5G network is quite a bunch of the different requirements is there, and like a massive IoT or mission critical IoT or more mobile broadband like real-time content streaming, and a bunch of the different application or network services requires a totally different functional requirements. And how that we make it happen with some cost-effective way for operator is a very critical, and 5G is like a more converged network to handle everything. And that's, you may already knew that, and almost no need to explain detail. But so what we did in the last year and what we can be next will be how we can handle the totally different requirements network services into one physical network. And so in this sense, virtualization is quite critical, but at the same time, how to achieve the such a how to achieve such a network service with some totally different, very ultimate network service requirements like a very ultra low latency or ultra bandwidth or almost no any failure, or like a mission critical things like a public safety. And in this sense, what we did is this one. But on the cloud, so next step must be, so how we can decouple the network service instance and from totally other things, like to must not affect anything. Even one particular service is down, it must not affect any other services. That's one of the challenges which we can make it happen. And by the way, so next question what we started, because many people talking about network slicing, but I'm quite sure. So if I ask there, what is your definition of the network slicing? I'm quite sure many people in each individual have an answer slightly different or totally different. Because when you are taking a look at the definitions and what the network slicing is, 5G America and the 3GPP and the ONF, each organization have a totally or slightly different definitions they have. Because that's quite obvious, because network slicing is not just one functionality. Network slicing is quite more end-to-end contextual things. It's almost impossible to define by one authority, because each entity, each organization has a totally different target services in mind. So that's why we are still a little struggling. So what the real network slicing is? Of course, in the high level, many people already have some level of the consensus. So in the that technical report published in last year, was they define the network slice instance as a more nested part of the network slice subnet, and the network slice subnet is contained some of the network function which may contain the VNF, virtual network function, and or PNF. Okay, on the other hand, given that I'm still involved in the NFV, and from NFV and or virtualization viewpoint, NFV's information model is quite simple, because we only have a network service and a VNF or PNF. VNF and PNF might be combined in the same network services, and the network service is nested. That's it. That's the only definition which NFV and NFV in general have a thing. And how we can mapping is such a network slice subnet or network slice instance into NFV model. So our understanding in the initial study was to such a virtual resources for the slice subnet and their connectivity to physical resources can be represented by the nested NSV network services. Or one or more VNF and PNF directly affected to the network service by the network slice. Those kind of more relationship is needed, and but still we have some question. So how network slice can be achieved in the end-to-end scenario? And a bunch of the technical challenges still we are facing, but network slice to realize a network slice is not only just technical solving, but also more than technical, because in many cases to secure the network slicing in the end-to-end manner, it's more than multi-site and multi-administrative domain orchestration is needed, and also how to secure the each resources which are allocated with each different services is totally different manner, even though those kind of resources and corresponding network function instance can be executed on top of the same physical network. And of course, in this sense, a priority to meet the customer's SLA is also very critical. This is a very last things because we just started, but management and connectivity for multi-site services is quite one of the important topic. And second will be, that's also more political things, but somehow we need to standardize, because otherwise that's kind of a roam in and roam out model in the mobile industry. Because the reason why 3GPP is so critical and the GSMA is also still critical across the mobile industry is simply because we need to secure the roam in and roam out across the different operator. And that may happen in the network slicing scenario in many cases, because even we assume to massive IoT, some supply chain supplier like a GE may have some region to be managed with some particular IoT sensor. But once those kind of sensor data is backhaul to the mobile operator, that's a totally different administrative domain is need to be managed. At the same time, those kind of things must be standardized in any way. Otherwise, anybody cannot secure the end-to-end network slicing and end-to-end network service scenario. Also, equally important from a technical point of view, this is not only limited to network slicing, but what I want to say is how to secure their resources. So, by the way, we are still struggling, still unclear what's the meaning of the resources. Because the resources is not only just a computing resources or memory or storage resource, but also at the end of the day, also user terminal, like IoT devices, also part of the resources. So how to secure such a resource allocation, including secure isolation from each others, is very critical. Because current OpenStack is now recently my former Docomo's colleague, not the Kebara's colleague, but my former Docomo's colleague, driving Blazor. So those kind of new OpenStack project is to meet the carrier grade requirement, especially focus on resource reservation and allocation. Otherwise, it's quite difficult to allocate some certain amount of the capability or capacity to enable, to allow any network slice instance to be utilized. That's one of the big purely technical challenge. Of course, other than that, there's still so many things we need to address. But I would say this kind of network slicing, resource allocation and isolation is one of the most critical things to be solved. Okay, thank you. It's almost one time. Okay.
So earlier in your slide, the different diagram with OpenStack, the B and switch and the TCP, those kind of diagrams. Is that a proof of concept?
Can you just go to the mic?
Oh yeah, his question is my one of the diagram for prototyping, so which we did with Intel and CASA, is an OpenStack and OpenHB basis. Is that just a feasibility study or something?
Yes. Or is it production?
No.
Okay.
Just a proof of concept. But I would say more than proof of concept, not only just for demo purpose, because we are already measuring performance and what is the bottleneck in terms of the throughput on the bus and also latency. We are still investigating. In this sense, because that prototype was in last summer, and since then, so we are more improving. So now, current stage is more than feasibility study, but still in the middle of the production.
So do you need to kind of make any customization with the OpenLV distribution in terms of scalability, stability, those kind of things, or just do the performance on?
Yes. Now, so in the context of the OpenStack, we are still just using Yardstick and FunkTest. But yes, you are right. So to meet the carrier grade requirements, scalability and availability is also very critical. But it's out of what OpenHB is doing. So that's why we are now doing in-house with our partner vendor.
Thanks for the presentation. Actually, you mentioned about the Intel platform that you are using for some of your implementations.
Mm-hmm.
So can you talk about, have you used DPDK or anything like that?
Yes. Is there any Eric? Eric is here?
Eric, no.
Oh yeah, Eric is a person in the Intel who are fully engaged on that area. So but yes, DPDK is obviously one of the key enabler.
Yeah, Eric actually did a tutorial in September, I think.
Oh, really?
It's from the Cable Labs. So,
Yeah.
So I don't know. Look for. I don't think that is up on our. Debbie, is cable lessons from Cable Labs? That's not up on our VNF page, right? No. Yeah. So I mean, if you're interested, we have that recording. We can share it. With you.
Yeah, but I would say DPDK and SRIOB is both of them are already used.
When you do network slicing,
Mm-hmm.
as the fundamental functions of net and all that, fundamental concept-wise, how do you do billing, operations and management, security, etc.? Is there any special features that you add to ensure that between the slices there's no crossover and billing is done based on usage, prioritization against becomes a billing issue as well?
Yeah, that's a very good question, and
Because for me, I'm from AT&T Bell Labs.
okay.
So we did not what you're talking about in an older technology, but the concepts do not change a lot. Where we had to do switch services and so on, we had to think about it, prioritization, how fast you do, and also respecting it and getting it off.
Yeah, that's true. And what we are now talking about in the context of the network slicing, because many people still have a different understanding. Like, for example, one particular network function instance can be reusable across the different network slice or not. So if that's the case, it's quite difficult to secure. So for example, but technically it's possible, but previously it's quite difficult from on top of the one physical computing resources. But now, given that all the computing resource and the memory and the throughput and everything is quite evolved quickly, so that's why somehow we can handle it, even though one particular VNA or network functions instance can be fully decoupled and each other, even in the exact same requirements. So then next step will be how many VM or container can be established on top of the one physical network. As long as we can separate and isolate as much possible, and it's avoided to reuse or recycle from one to another, somehow maybe we can fully kind of isolation might be realized. That's the current stage.
In software-defined multi-tenant services that you have provided,
Yeah.
I'm putting gentle words.
Yeah.
It just can put it into whatever.
Yeah, but this is just for inside the data centers, how to manage it. But network slicing is, as you pointed, it's more than that. So for example, how we can manage such edge computing resources to be logically separated, it's quite difficult at this moment in time. So that's why we are now starting from a central office in more data center side, and then more expanding to leverage those kind of technique into.
Issues in the east-west traffic, not only south, not south.
Yeah, not only just north and south, but also east and west as well. Yes.
Hi. Do you know Ho Kim from Cable Labs?
Who? Oh yeah, of course, that's my colleague. Yeah.
Oh, that's your colleague.
Yeah.
We were accepted last year to the WBA Alliance in New York.
Yeah.
We presented software-defined radio where we can do 4G,
Yeah.
EPC, the HLS, all in a USB stick, and make it so that it can be plug and play for any Intel general purpose computer. My question for you is, they were interested in prospectively working with me in
Curio. Yeah.
Curio, with regard to testing software-defined radios.
Yeah.
Is that something that Cable Labs has started that you're aware of?
Yes, of course. That's next to my desk. I'm not personally involved in that project, but that's a good point. That's a little bit, ongoing parallel. But at the end of the day, those kind of SDR must be integrated with small cell, especially in the 3.5 and the CBRS. That's exactly our not me, but more cable operators' intention. Yes.
Exactly right. Very
Yeah.
good, thank you.
Looks like there's one.
Okay.
Thanks for that. Nice talk. So, question about the OpenStack.
Mhm.
You mentioned that the resource isolation, allocation, thing like that. What's wrong with OpenStack? Why you move away from that and you want to go with Kubernetes and Docker container, you mentioned? Do you think it's two in a parallel, one on top of the other one, or to be replacement OpenStack, or what's wrong with that?
No, sorry, don't get me wrong. So what I'm talking about, still we are focusing OpenStack, especially in Blazor, to make it resource allocation and reservation happen. But at the same time, what we are now doing at the same time, or totally differently, is how we can, make a very similar functionality with Kubernetes and container. That's a totally different project. Yeah, because it seems like a timeline. Because many people is very over expecting about their container. But my honest opinion, my personal, not company, but my personal impression is still a container, especially including Kubernetes, is quite still difficult to manage in the carrier environment. So that's why still we are trying to make it more carrier grade requirements with OpenStack first, and then move to a more container side. Yeah. And also cloud native. Okay, thank you.
Thank you. Thank you, Tetsuya. For AI analytics of the network platforms too. She has led the architecture efforts for machine learning and deep learning solutions, including customer engagements with impactful design wins. She has 50 US patents and over 70 publications to her credit. She's a member of IEEE's Multimedia Technical Committee, Vice Chair of the ACM SIG-MM Bay Area Chapter, and co-organizer for the Bay Area Multimedia Forum. She earned a PhD in electrical engineering from University of Southern California. So please welcome Tong. Thank you.
Yeah. Okay. Let's do full screen. That's not working. Okay, there we go. Why isn't it? Put it over here.
Wow. So I control the slides, just use this, right?
Yeah. Wish there was a better way to do this. Sorry. Let's try doing this. Where is it now? There we go. There we go. Okay. Now you'll be able to just use
Okay.
Yeah, page up, page down.
Okay. Okay. Thank you. Yeah. Okay. Yeah. Yeah. Good afternoon, everyone. So I'm talking about our AI, our applications in telco, the use cases, and also our Intel's our hardware portfolio and software stack in supporting the use cases. We know that our AI is transformative across industries. So here we show our use cases are in different verticals that we have been working with our customers and partners with. So the use cases are in the yellow boxes. Those we identified as more network domain specific use cases, such as like cybersecurity, like network edge analytics, or self-optimized network, and so on. So these are, I'm from our MPG, the Network Platforms Group. So these are the use cases that are, we are focused on from our MPG. There are also other use cases that are related to network domain, but also our needs are synergy with other verticals, like our smart city, like our autonomous driving, like our retail, and so on. So these are the areas that we're working with other groups, such as IoTG, PSG, or AIPG, and so on, are within Intel. In our network domain, we see our use cases are in two categories. One is around our network core services, like our revenue assurance, like our self-optimizing network, self-healing network, like our service assurance, like predictive maintenance, our network fault, our detection and localization. So there are quite some use cases, basically around the network operation. Another category is our, kind of like a hybrid network core and edge. So for example, we're talking a lot about edge computing. So a lot of applications are, for example, IoT applications, are like our video surveillance, are like our autonomous driving, our cars, our drones, robots, our smart manufacture. So these are kind of like related to our computing at the edge. A lot of our media computation, video analytics, image recognition, speech recognition, for example, for our smart call center. So a lot of media analytics, a lot of our machine learning, deep learning are over there. So this is our, what we see as our, our growing our edge computation, our use cases. So the upcoming 5G and edge services we believe that AI will play a key role there. We have seen like a potential and will be our fast growing areas like our industrial control, in our manufacturing, agriculture, and so on. Our smart cities are including like surveillance and information from other sensors, from all kind of like sources, for various kind of like smart functions, right, around the city, in campus, in their libraries, in the hospital, and so on. So our autonomous driving I mentioned, our VR gaming, retail, there is also a transformation of the traditional CDN business. So we anticipate a lot of our use cases, a lot of our data to be generated, to be processed, and AI would be the core our technology are over there to drive this. So I talked about the use cases. And now let's just go to a little bit about the basic of AI. People talk about machine learning, deep learning a lot, but we would say that AI is a big umbrella, and then under this umbrella there are different approaches. Even though we have heard deep learning so much the last several years, but it's just one kind of approach under AI. So deep learning we know basically is neural network. And neural network is just one type of our machine learning methods, right? And especially deep learning is about our big scale neural network, deep, and large network models, which has proved to be particularly useful to process a large amount of our especially unstructured data, such as our video, image, audio data. So for our applications like facial recognition, like image object recognition, our natural language understanding, speech recognition, and so on. Besides deep learning, there are also other methods of machine learning, and now we often call it classic machine learning, or non-deep learning machine learning, or traditional machine learning. Methods like SVM, our random forest, are a lot of regression methods, are also unsupervised machine learning, like k-means clustering. There are quite many types, many different methods for machine learning, which basically are use data either labeled and unlabeled to train our mathematical model, to help to do our reasoning or making decision from data. And actually, in the telco domain, we have seen a lot of our problems, a lot of use cases where actually we can use different kinds of machine learning methods to solve the problems. Yet another approach of AI is cognitive reasoning, which is not necessarily you have to build a mathematical or statistical model like in machine learning, but maybe you can build a reasoning system which could be composed of heuristic rules or certain kind of designed procedures. It could be memory based or could be logic based. So that's another type of AI, which can be used for example, for fraud detection, for our certain kind of predictive maintenance, and so on. So in general, we see that for the telco domain, for the different use cases, it could be we can use our methods in any of these different categories, or it could be a combination, a mixture, of these different categories. We believe that AI adoption is just beginning, even though it sounds like everybody is talking about it, and when we are meeting with our customers, nowadays our AI is always a topic. So we talk a lot about AI, but actually in terms of our AI adoption, we're really just at the beginning stage. Especially in our telco domain, we have seen that almost all the big companies, major customers are thinking about using AI, and there are also quite a number of startup companies are looking into this field. But in terms of deployment, it's still like not that many. So I would say the majority of our people are still at our exploratory stage to see how we can use AI. So in Intel, we are working with our customers, and helping our customers in this journey. So this is overall offer to our customers and partners. So at the lowest layer is our hardware. So this is just the computing hardware that we have for AI, not including our networking, our storage, memory, hardware. So just for the computing side, we have our CPUs, our Xeon Core Atom. We have our FPGA, our Area 10, Stratix 10. We have our own GPU. Right now, the integrated GPU. In the future, we may have our discrete GPU. So we have our GPU roadmap. We have our ASICs. Our large form factor ASICs to be used in the cloud for deep learning training. We also have very low power ASICs to be used at the edge. Above the layer above hardware is the libraries, the low-level libraries for acceleration. So we have especially our libraries to accelerate deep learning, or to accelerate machine learning. We have our own Intel distribution of Python. So these libraries take advantage of the particular hardware features of Intel platform, so that it can accelerate the speed in many times faster. And then the layer above the library is the framework library. So Intel, we have optimized most of the popular, widely used frameworks nowadays, including the popular deep learning libraries like Caffe or TensorFlow, MXNet, and so on. And also machine learning libraries like our scikit-learn, and our Spark libraries like BigDL, MLlib. So we have made a lot of investment here. Many software engineers are doing a great job here to optimize these open source libraries. So all frameworks, all these frameworks are open source, and everyone can get access to them. And then above the framework layer is the platform layer. So for people who don't have a deep background in machine learning and AI, or who just don't want to spend too much time investigating how to use TensorFlow, how to use the BigDL or whatever, right? So you can just use Intel's the tools the platforms we provide. So for example, we have Intel Deep Learning Deployment Toolkits, which can just take any trained model, model you train from any our framework. So just you take the trained model, optimize the model, deploy the model. So basically, users don't have to be concerned about the framework layer, the library layer, or the hardware layer. We also have our Intel Deep Learning Studio for training. Of course, if you use our reasoning system, Intel Saffron, we have the SDK for that. If you use our Movidius, our ASIC for vision recognition tasks, you can use our Movidius SDK. So we have a bunch of tools and SDKs for that. And then finally, our highest layer is about the various kinds of use cases in the different domains, right? For 5G, for our SDN, for our autonomous driving, for our smart manufacturing, and so on. So we have having our case studies, POCs, or deployments with customers in these different areas. So a little bit more about our computing hardware. For general AI, which basically I would say non-deep learning AI, so our mainstream hardware for general AI is our CPU. So I would say that we have made a lot of investment and improved a lot the hardware and software stacks for our CPU to be used for AI. And if you need acceleration, we have our FPGA. So we would say for general AI, mainstream is our CPU, and then FPGA for flexible acceleration. For deep learning in particular, there are two sides, the training side and the inference side. So for training, normally training is done in the data center, and then the mainstream training hardware we would recommend to our customers is our Xeon, our Xeon server. So I will show a little bit later, how much progress we have made on our Xeon server for deep learning. And then of course, we also have the Nirvana neural network processor, the ASIC NNP, for intensive training. So basically, our Xeon as our mainstream training plus the intensive training performance from our NNP ASIC. For the inference, again, there are two subcategories. One is to do inference at the data center, and here, again, our mainstream, our inference, our hardware is Xeon, and then the FPGA would be, if you need real-time inference, we would recommend our FPGA as the accelerator. And then if you do inference at the edge, actually nowadays more and more use cases, I also mentioned a little earlier, more and more use cases to do our inference at the edge and gateway. And here working together with our CPUs. It could be Xeon, could be Core, could be Atom CPU, depending on where the inference is done, is on the camera, on the device, or in our base station, in the central office, depending where it is used, right? You may choose different kinds of CPU. And then besides the CPU for acceleration, it could be our integrated GPU for higher inference throughput. It could be our Movidius ASIC for low power visual processing. So for example, for image recognition, for our video detection. So our Movidius chips is around 1 to 2 watts per chip. So it offers the best performance per watt. The best throughput per watt performance. For speech recognition in particular, we have something called GNA. So that is our IP, very low power, less than 1 watt for speech recognition. For autonomous driving, we have, of course, the Mobileye system, and we have our FPGA. So it really depends on where you do the inference, the workload, the specific use scenario, you can choose, among this portfolio. So a little bit about our Xeon processor. So here this is a comparison. The current Xeon, the Skylake, this current generation of Xeon server, Skylake, comparing with the Haswell, our CPU, and also with our software improvement. So now we are in terms of inference throughput, we're 198 times better, Skylake versus Haswell. And then in terms of training, we're 127 times better. We show this because sometimes we got compared, or other people would compare with us using our older generation of our CPU and also using our non-optimized software. We want to say that we have made a lot of progress, both in terms of hardware features and software. So we are comparing with the older generation of our products, we have made this significant progress. I mentioned about the libraries. Just get a little bit more detail. We have, people probably know about our math kernel library, MKL. That is our software, our library product that we have had for many, many years. But recently, we also built something called MKL DNN. So this is a subset of MKL that we made open source, in particular for deep learning usages. So a lot of the commonly used deep learning primitives are optimized and open source, so everybody can get access to the source code. So MKL DNN is very important to use if you use Intel architecture to do our deep learning tasks. Our CLDNN is to support our Intel GPUs. So it's about the same level as MKLDNN, but MKLDNN is more for CPU and CLDNN is for GPU. So the DAAL is a library for traditional machine learning, for supporting machine learning methods like SVM, like k-means, or random forest, and so on. So MKLDNN is for deep learning, and DAAL is machine learning. Our Intel Python distribution, so this is our Intel's version of our Python. It could, if you use our Intel Python distribution, comparing with the our general version of Python, you can get from dozens to even hundreds times of speed up. This is important to know. We also are developing something called Intel ngraph library. So as shown in in this figure, so this ngraph library is our abstraction layer between our framework and hardware. So basically, it can work with any kind of framework and then any kind of hardware. So for users, you don't have to worry about what framework you choose. Through the ngraph, it can automatically be your code will be optimized for the hardware underneath it.
Is that also open source?
Yes, ngraph is open source. Yeah, so it's our ongoing work. Yeah, but in our AIPG, or within Intel in AIPG, a lot of software resource is put in there. So that is one of the major investments we're making in Intel to support our AI. Yeah, yeah. So I mentioned about Intel distribution of Python. What I want to emphasize here is that our Intel distribution of Python, you just install it exactly the same way you would install a normal Python. So it's made really very easy. So you just install it instead of a normal Python exactly the same way, and then you will get the speed up automatically. So NumPy, SciPy, scikit-learn, and so on. So these are all have been optimized. So you will see the speed up, significantly. Our frameworks I also have mentioned. I talked about popular deep learning frameworks like TensorFlow, Caffe, MXNet, or Caffe2, Syndicate. So we have worked on all of these, and especially for customers, because many enterprise customers use Spark, and then if you use Spark for a lot of your operations, and now you want to add some machine learning or deep learning functions on it, it's not easy for you to use our TensorFlow, Caffe type of thing on top of Spark. So in Intel we initiated an open source project called BigDL. So BigDL is basically to provide our deep learning functionalities on top of Spark. So it has been there for almost 1.5 years, and it has been very popular. So we helped quite a number of big customers in different verticals to deploy it, to use it in production. This is something I want you to know. Our AI tools I talk about, we have the Deep Learning Studio, we have the deployment toolkit, we have the Movidius SDK, and so on. So so you can just use these easily without knowing the details of the layers underneath. So back to our telco. Within our Intel, especially within our NPG, so our focus area on AI and supported by the hardware portfolio and the software stacks I just mentioned. One area of focus is, of course, network analytics. And then within network analytics, there are a few topics around network operation we're working on. So our one topic is our service quality assurance. Another one is our security analytics. And then yet another one is around anomaly detection for security. And then another area is for user data analysis. So the difference between these two, of course, our network operation is based on our network operation data or telemetry data, especially our telemetry data, our log data, our analysis. While user data analysis is based on the user behavior, or user history data, and so on. So for monetization of the user data, so we have seen our strong demands from our customers for both sides. Another area is around 5G and edge computing, because certainly these are the very hot areas. And we are also actively seeking opportunities to do some POC with our customers in this aspect. So we are possible our topics could be around our surveillance system or autonomous driving, or like a fog computing in our manufacture. And then the third area is around media processing. I mentioned that media analytics is growing pretty fast. We see a lot of use cases. We got a lot of our requests from our customers to get our support there. So for example, for smart call center, voice bot, chat bot, based on speech recognition, based on natural language understanding, these applications are growing very fast, and we need to provide their solutions to our customers to support these tasks. I mentioned about our service assurance system. So our Intel, we have built this this stack to collect telemetry, our data for our for virtual EPC, for virtual CMTS. So we have collected our large dimension of our telemetry data, and then we want to we're doing our analytics on such data to do our telemetry compaction, so that to identify our small set of features that are related to particular KPIs for KPI prediction, and also for our closed loop, our optimized operation. So this is one topic we are looking into. Another example is around cybersecurity. So our Intel, we actually initiated our open source project called Apache Spot. So this is an open source one, so available at GitHub. So this one is basically the inputs are from the log data. So base get input from several log files, and then set up our Spark-based data streaming and processing our platform, and then we apply machine learning algorithms on top of it. So especially it's based on the Spark MLlib. MLlib is our machine learning library for Spark, and Intel has done quite a comprehensive optimization of this library, so it runs efficiently on our Intel architecture. We build machine learning algorithms here to detect anomaly in the log file data, so that if there is something unusual or suspicious happening, we can get the alarms. So this is our cybersecurity use case. So we are also actively being involved in some community activities. So one is the Acumos. Acumos is a Linux Foundation open source platform for AI. So it was just launched recently, actually last month during ONS in Los Angeles. So it was started by AT&T and Tech Mahindra, but right now there are quite a number of big companies already joined Acumos. So basically the goal is to set up our AI platform and marketplace, so that people can different companies can share their data and their models over there. It supports several. Right now, it supports scikit-learn, TensorFlow, H2O, and the R Cloud. It can take additional popular, commonly used frameworks, so that people can develop their own models, and then contribute the models, onboard the models to the marketplace, and then you can refine models from others, and so on. So it is at a pretty beginning stage, but a lot of things going on over there. As I said, quite some companies have joined. And of course, for Intel, we want to play a important role there, especially to by contributing our Intel architecture-based solutions. And another activity is our ENI. Our ENI is a working group under the ETSI, our standard body. So this is our basically activity in building a new standard particularly for using artificial intelligence techniques in the network management system. So these here are the use cases that have been identified by the ENI members. So are in 4 areas: network operations, network assurance, service orchestration and management, and infrastructure management. So these are the identified use cases. And right now, ENI is at the stage, where members are making proposals for POCs around these use cases. So at the end, I'd like to introduce to you Intel. We have this website called Intel AI Academy. There are tons of very useful information over there. So if you want to learn about our AI, there are classes, tutorials. If you want to use or try Intel our solutions, there are Intel optimized links to Intel optimized frameworks, to our access to Intel AI Dev Cloud, or if you want to share your opinion or get some technical support and so on. So a lot of things you can do over there. So very informative place. Yeah, and finally, we encourage you to use Intel's performance optimized libraries and frameworks. So try our stuffs. We have put enormous investment in Intel in putting together these solutions, in making optimizations on our hardware and software. So please try these, and then and also we're looking for partners to do our POCs and our other things with us. So if you're interested, please contact your Intel representative, and so that we can work together in this new domain. Thank you very much.
Thank you. Questions? You have the mic next to you.
That's why I said it. So it's very impressive about AT&T's Intel's involvement into AI. So will you have some kind of like a workshop or training how to use Intel platforms maybe down the road?
Oh yeah.
Later?
Yes, certainly we have done a lot of kind of like workshops and training, or either at the customer side, or say for some of course big companies, right, where they have a lot of people interested to learn what we have, right. So I have participated in some of those myself, and we also, I think we have some webinars, all these kind of things. So let us know. As I said, contact Intel representatives, for example, our account teams. Or you can just send email to me directly. So yeah, so let us know. We have put together a lot of materials for training. Yeah.
Thank you so much.
Thank you. Yeah.
So I also read that Cisco is doing a lot of stuff on the networking side. They're working with IBM for Watson AI. They're doing exactly the same thing. I was just looking at Saffron. When putting in a Cisco switch, whatever you do, you could replace Cisco. So what do you think? I just want to know, what is the...
So you mean replace Cisco?
Yes.
Yeah. I mean, Cisco, of course, is a major customer of ours. So we have been, honestly, I don't know whether there are people from Cisco here, but we have been trying to, we have had conversations with Cisco, and we have really been trying to push for opportunities to work together with Cisco on some, collaborating and for some POCs, for, or also maybe involve some third-party end customer, like an operator, whatever, right? So we have been doing that kind of thing. We also, just as you said, we heard that Cisco has done a lot in this area. We're also trying to understand better what they have. So yeah, so thank you for bringing that up. So we will find a way to work with them or to understand better. Yeah.
See, because so the reason I'm saying it was at an IBM Think conference,
Mm.
and what are the use cases you are trying to solve? Cisco is trying to do the same thing.
Okay. Yeah. I mean, thank you. Yeah, thank you for letting me know. But yeah, so that's understandable. Honestly, Huawei, which is Cisco's major competitor, they are also looking into this, right? So because their customers, the operators need this kind of thing, and they're our customers, Cisco and Huawei, and then we also work directly with the operators. So you can understand the relation over there, right? So yeah.
Yeah, thanks for covering such a broad range of applicable areas. The question I had is just if you could talk through an example POC process, like with the text recognition one for logs or something like that. So how you go about doing data gathering and assessing the data and then testing models and then deploying it. That would be great.
So you like to see going to the details of one particular example, right? Yeah. So thank you for that suggestion. I probably don't have time here today, but I think that's a good suggestion. We will be putting together some white papers or some blogs, so for each of the. So I am in the procedure of driving for getting some case studies, because I think that's what customers and partners are really looking for, right? So to get some real kind of case studies with details about how you apply AI for a particular network analytics use case. Yeah, thanks. Okay, is there no more questions? Thank you, Tom.
Thank you.
Yeah. Thanks, everyone.
So just to add on to Tong, I was just mentioning that we are also funding some early innovation projects. So this cycle for Q2, we have funded 2 projects on AI and networking at the cross-section of AI networking. So I don't have the slides up on the projects that we decided to fund, but the innovators that we are funding is Frederick Fox and Dave Oscar. So Frederick's projects is around building and collecting data samples to use in AI networks. Dave Oscar project is around creating smart NIC kind of framework using FPGA and regular NICs. So yeah, we'll see how those progress. So now time for some surprise prizes for the audience. Can I have you, Tom, to just pick one of the tickets? So it is 472232. Who has that ticket? Ah, do we have the price for that? Ah, okay. Ah.
Tetsuya, can you draw another one? Yeah. So 472206. Ah. Yeah. One more. A volunteer from the audience. Okay. Don't pick your own ticket.
Unless you're really lucky.
It's 472219. Four seven triple two one nine. Ah, okay. And as a thank you to our speakers, have them on stage. Thank you. Ace, a picture, please. And we can have the winners, the three winners, also, up here on the stage. Yeah, the name. There was one more winner. Thank you. So now we have about 15 minutes break for tea, coffee. We'll meet here back at 3. Thank you.